Unit 6, Day 4. Infinite geometric series.
Oh, is this whenever you're going to show us the blowing our minds thing?
Yes, this is going to blow some of your minds. Hopefully in a good way, maybe in a bad way. Hopefully not literally for anyone. That would be bad. And messy. That's right. I don't want to have to clean it up. So, what is the sum of an infinite number of positive, that makes it a lot harder, numbers?
Just be infinity plus all those numbers.
Infinity.
Right? If I didn't say positive, you could say, well, I could add up an infinite number of zeros and get zero. And like, that's right. But they're all positive. So you're right, it's usually
Infinity plus or minus infinity.
Usually infinity. Right? If I add up an infinite number of ones, eventually I get to infinity. Even if I add up an infinite number of 0.001s, like eventually you're going to get to infinity. Usually.
As soon as you start on the constant thing, it's already infinity.
The usual thing. So let's take the example of painting a wall.
The room gets slightly smaller.
Yeah, just like if you fold a piece of paper, it eventually gets to you. If you fold it.
And each day we're going to paint half of what's left. Let's draw a picture here. Half of what's left.
That's simple for paint.
Oh, some of you are already thinking ahead, and that's good. So day 1, here's my wall. Perfect square, makes it easy to keep up with things. I paint half of it. We're going to try to make a table here.
Can't see it.
So we're going to have 3 columns in our table. What day it is, how much we painted that day, and then the total amount we've painted. Day 1. How much of the wall did we paint that day?
Half the wall.
Half the wall. So at the end of day 1, how much of the wall is painted?
Half the wall.
Half the wall.
No. Day 2.
Okay, that was the easy part. Day 2. That part's already painted. We want to paint half of what's left. Bottom half, top half, doesn't matter. Day 2.
Exponentially half.
How much did we paint that day?
1/4.
1/4. How much total painted of the room have we painted?
3/4.
3/4. You guys are fraction experts. You didn't even know that. Let's keep going.
Oh, geez.
So day 3, we already have the
5/8.
half and the
Yeah.
half and the fourth painted. So now we're going to paint half of what's left.
And 2. I'm doubling.
So how much? Well, that's day 3.
5/8.
How much of the wall? What did we paint that day?
1/8.
1/8. And how much of the total wall is painted?
7/8.
7/8. Yeah, 7/8. Let's do one more picture because I like drawing these
15/16.
pictures. Oh, you're way ahead of me. Yes, 15/16 is the final answer there. But come on, let's draw the picture.
No.
So you're just doubling
I like how stupid possible.
Yeah, just have a small.
Yes, this is not the best way to paint a room, for sure.
Why your wall look like that?
Day 4. We painted the 16th of the wall, and you're right, 15/16. I don't want to draw another one, but just to make sure we got the pattern down.
31 30 seconds.
On day 5, how much do we paint, first of all?
137.
And how much total is painted?
31, 32.
So
31, 30 seconds. So, a couple questions. There's sort of two ways to ask the question now.
62, 60.
The question is, when will we finish the wall?
technically never.
Never. I like that answer. Never. We'll never finish the wall.
Well,
But at some point
you won't
will
have a
be able
paintbrush
to.
small enough to get
And we won't have a paintbrush small enough to, you get out a toothpick and dot the little piece that's left on day 10 or 12 or whatever. Let's come up with some.
the folding the paper.
Let's not do formulas yet. So yeah, you'll never paint the full wall. That's true. I agree with that.
Even when you paint the
And this is where it's hard to think because our brains aren't really wired to think in terms of infinity. But if you could get to infinity, if you had forever,
you still have some there.
well, but you'd always paint it tomorrow because you got tomorrow. You're never going to run out of days. So this is like a limit problem. As we go toward infinity, well, actually that day would be toward infinity,
I'd like to see someone try to do that.
we wouldn't have much to paint.
It'd be 1 over infinity.
We'd have, it'd be 1 over infinity, or it'll be, let's back up here. Day is n, 1 over 2 to the n. So on the 10th day, we're doing 1 over 2 to the 10th wall, which isn't much of the wall left. And this would be 1 minus 1 over 2 to the nth. Right? Because it's always 1 minus whatever we painted, because whatever we painted is also how much we have left. So 1 minus whatever's left. But if this is going to 0, as we go to infinity, then
This is like the thing that was.
when we're at infinity, it is like an asymptote. Is that where
No, the other, the one that.
it's an asymptote behavior. As n goes to infinity, how much of the wall is painted?
1.
If you could get to infinity. Now that's the tricky part. It's like, well, I don't have an infinite number of days
You can never get there.
because I won't live that long. But if we took it to infinity, but you can't ever get to infinity. This is why we have limits
We were doing this.
in calculus. The sum is 1. So will we ever finish? No.
Until someone comes up and just paints your wall.
But with infinite days, the sum equals 1. And that's the tricky part, because like infinite, you don't have infinite days. Right, but if you did, the whole wall would be painted. As a limit. The limit as n approaches infinity is 1. Here's another way. It's almost the same problem. If you walked halfway to the door, and then a minute later you walked another halfway to the door, and then a minute later you walked halfway to what's left, would you ever get to the door?
Not really.
Not really. That's the best answer. Like, kinda. After 7 or 8 iterations, you're, like that far from the door. Are you at the door? No.
You're at the door, just not through the door.
And you're definitely not going through the door. But if you did that an infinite number of times,
You can't measure that.
you would get there.
You'd be passed out on the floor.
You'd get there. You'd be old, but you'd get there if you had an infinite number of times. So that's the tricky part, is sum as n goes to infinity. It's like, well, I don't ever get to infinity. And we're like, yeah, I know, but if you did, what's the answer? And that if you did thing is a limit process. And we do that a lot in calculus. This is just sort of dipping our toes in the limit process. So here's the formula. Actually, let me ask before we do the formula. This is a geometric series. What's r equal to in that series? Like, look at the terms. R equals 1/2. You're multiplying by a half each time.
Will, who's that?
That's important. I'm not even going to write this one down. We'll just talk about it.
You know, right?
What if you walked a mile today, and then 2 miles tomorrow, and then
No.
4 miles the next day,
Once you
and
get a
then
week done,
8
you're-
miles the next day? At the end of, like, what would the total sum be at the end of
a week.
infinite days? Not a week, infinite days.
Circumnavigation of the
Infinite
world.
square.
Infinite. You just go on. You just keep walking. Like, it wouldn't work. And that would be if R is 2.
Absolutely. You can still bolt it.
So you'd have 1 plus 2 plus 4 plus 8 plus
At that point,
16.
you just ran out of daylight.
And if you did that forever, there's no limit. Like, that doesn't work.
Well, human limit, but yeah.
So there's something really important about what R is as to whether this works or not.
One gets smaller, one gets way bigger.
And it's exactly that. If the terms get smaller. If the terms get smaller,
But if you're just gonna double it every day, then it's just
so that would not be R equals 2. But if the terms get smaller, the sum will work.
but if the terms get bigger,
Then you're going to be there a lot.
In fact, work is, here's our magic word, it will converge. We'll have an answer. As opposed to diverge. Not have an answer. So, we're really close to sneaking up on this formula here. Or at least part of the formula.
But it's
If the terms get smaller. So what does R have to be to make the terms get smaller?
less than 1.
If R is less than 1, then we can use this formula. Now, that's an important part of this formula because you can use the formula and get the wrong answer, but you're only allowed to use the formula if R is less than 1. And really, we have to be careful because it's the absolute value of R has to be less than 1, meaning R could be negative. So if R is negative a half, it still works. If R is negative 2, though, like if you run a mile forward today and 2 miles backward the next day and 4 miles forward, that's never going to add up. That's going to be infinite.
You'll just walk backwards. As you walk.
The formula is super easy. This is the kind of the strange part about this one. A1 over 1 minus R.
That's it.
That's it.
Yeah, wait.
That's it.
Yes. Wait.
The first term
It's all.
over 1 minus R.
So the first one.
But only if R is less than 1. If R is not less than 1, here's the trick. If R is more than 1, you use this formula, you get an answer, but it won't be right. So you've got to be careful about R being less than 1.
So if R is like greater than or equal to, would the series diverge?
It would diverge.
Cool.
If R is 1, that means it's the same term every time. If you walk a mile today and a mile tomorrow and a mile, and you do that forever, you're going to walk an infinite number of miles. Let's do some examples. So, the algebra for this is easy. The calculus behind it is a little bit tricky. And being careful with R is a little bit tricky. So the formula is great, but it's more about can I use the formula. So if I want to find the sum of 40 plus 20 plus 10 plus 5
It's
plus
R is half. ...
That's what we need to answer first. R is a half. So are we eligible to use this formula?
Yeah.
Yes. So first term over 1 minus 1/2. 40 divided by a half. Some of you can probably just reason that out.
Wait, why did you take out
We
the
re-lose.
41 is 1. 1 minus 1.
1 minus
Yeah.
half is half.
Yeah, okay.
And then, so some of you know what that is. Others are going to keep it, change it, flip it. We get 80.
80 what?
80.
That's the answer.
That's the answer.
Oh, of like all of those numbers.
Of all of those, if we went forever, they would add to 80. And again, it's still weird. You're like, well, you can't go forever. I know, but if we did, you'd equal 80.
Wouldn't it be like 79.9 repeating?
No. Although, hold that thought at the end, and I'll blow your mind again if you want it. If you want me to try to shatter your brains on the floor of the math room here.
I'm sure. Yeah, this part is gonna just mess up the whole test.
Yeah, your test grade's about to tank.
Can we do a grade test?
Nah, the formula's easy. Formula's easy.
Like what? Doesn't like
A1 over 1 minus R.
your test?
Alright, so the sum from n equals 1 to infinity.
Math teachers always
Ty?
say that forms.
Could you show example 1 for just a second?
Yeah. Oh, we were joking earlier about using the calculator to check these, or trying to check them by hand even. You can't check these by hand,
Oh, you can check and
because you can't ever get to infinity.
Yeah.
It's like you can kind of get close. Let's see, that'd be 60, 70, 75,
There's not even an infinity.
77.5.
It's the only infinity.
It's
Yeah.
0.75.
Even if you wanted to keep going with decimals, you would never get to 80 because you would stop.
Oh, yeah, you would stop growing.
But we're not going to stop. We're going to go to infinity.
That's kind of infinity. It's just the E on the calculator. Is there actually an infinity button?
Example 2. Sum from n equals 1 to infinity, negative 2/5 to the n minus 1. Infinite sum, so we need to figure out what R is. Can you tell by looking what R is?
Yeah.
Five.
Negative 2.
Oh, there's infinity.
Well, if we're not sure, let's find the first couple terms.
Wait, why do we start with what's that?
So rather than, it would be great if we could tell what R is just by looking,
A.
and maybe you can, but if not, let's figure it out. And besides, we're going to need A1 anyway if we're going to use this formula. So 1 minus 1 is 0. Anything to the 0 is 1. Times 5 is 5. But that didn't tell me what R is. A2, 5 times negative 2/5 to the 2 minus 1. So that would be 5 times negative 2/5. Be negative 2. Are my terms getting smaller?
Yes.
Yep.
Well, do like 3.
Let's go one more. 3 minus 1 would be squared. This is going to be yuck. 5 times 4/25 is 4/5.
Yeah.
So it got bigger, but I don't care about the signs. I care about the magnitude of the terms. The magnitude of the terms are getting smaller. 5, 2, 4/5. The numbers are getting smaller. So R is less than 1, but what is R? Well, if you're ever not sure, you can take any term and divide it by the previous term.
Oh.
We didn't get a review for this one. Ouch.
There's a review in there, isn't there?
Oh.
So R is negative 2/5. So am I eligible to use the infinite sum?
Yes.
Yeah. So we're good. So A1 over 1 minus R. First term is 5. 1 minus negative 2/5. Oh, now for some fraction work.
Minus, wait, it'd just be
Minus minus would be plus.
7/5.
7/5. 5 divided by 7/5. How about we keep it, change it, flip it?
Yeah.
5 times 5/7.
Change your void to a fraction. If you
25/7. That one would be really hard to check by hand, right? 5 minus 2 plus 4/5 minus 8 1/25. I don't want to check that one. Example 3. Nine plus 12 plus 16.
It's not gonna work
Why not?
because it's getting bigger.
Right.
And it diverges.
That diverges, and the sooner you recognize it, the less work you have to do.
Wait, is that
That diverges. We're done.
Yeah.
The terms are getting bigger. Now, if you wanted to see what R is, 12 over 9,
Wait, is it a meter?
or 16 over 12.
No.
It's not an either. It's geometric.
Yeah, you just
But R is bigger than 1. So it diverges. That's our answer. We're done with that problem. The trick is you can get an answer. A lot of times in math, like if you mess something up, like eventually you figure out, that didn't work. Here, if you use the formula, you will get an answer. It will be wrong, but you will get an answer. And if you're paying attention, you shouldn't even get there. Like 9 plus 12. I'm adding bigger numbers the whole time. This is not going to work. And it's fine to stop there and say, that diverges. I don't need to go any further. Let's do one more. Sum from n equals 3 to infinity of 2/3 to the n plus 1. Well,
I think it's smaller.
is it geometric? I guess that's our first question.
Yes. Yeah.
It's a big thing.
Yeah, because
Yeah.
Uh-huh.
Yeah, let's figure out what R is then. If there's an R, then we know it's geometric. So, and we have to know R to know if we can use the formula. And we have to have R for the formula. So, we're going to need R anyway. So the first term, this is a little bit weird. What is the first term going to be?
Oh,
2/3 squared.
Yeah, I plug in 3 to get the first term, since we're starting at 3.
Oh.
That's so annoying when that happens. So 2/3 to the 4th. 2 to the 4th is 16. Yep. 3 to the 4th is 81. Well, do you know what R is? I don't really want to find the next term because it's such a pain. Can you figure out by looking what R is going to be?
can you just
That's as far as that'll go. I mean, I guess I could do the next term.
simplify it by saying R is
It would 32 over 81 times 3.
not enough information.
R does exist. What are we multiplying by to get from this term to the next term?
X.
2/3.
So the R just gonna be the number in the parentheses.
Wait.
Yes.
Oh, wait.
Yeah.
Yeah.
Yeah, why?
Kind of depends on this exponent, so you do have to be a little bit
It's
careful.
n
What
plus
do you
1.
mean?
So our infinite sum, what's the first term of this series going to be? We got lots of possibilities here. I know what R is. Okay, so be careful. In the formula,
15 to 1.
I don't need to get back to 1. A1 means,
1 is
it doesn't mean plug in 1, it means first term.
So 3. This is a 16 over 8.
So the first term is 16 over 81. That's the first term. We started at 3, which is what messes this one up, but the first term
16 over 81.
is 16 over 81. Well, yes, it looks bad, but once we get going, it's not that bad. What's 1 minus 2/3? 1/3. So keep it, change it, flip it. And the 3 and the 81 reduce. So we end up with 16 over 27. All right, you want a math joke to end the lesson? She's like,
Lowest number.
I don't
not
really
really.
know mine.
I'll blow your minds in a minute.
Alright.
Let's do the math joke first. An infinite number of mathematicians walk into a bar.
You walk out.
The first one orders 1 pint. The second one orders half a pint. The third one orders 1/4 of a pint. It's kind of this thing.
That's why there's prohibition.
The third one orders 1/8 of a pint, and so on. And finally, the bartender says, "Boys, here's 2 pints. Know your limits."
Oh my gosh.
Because if you add up an infinite number of what they were doing, you would get 2. Because it was this same formula with a 1 at the front of it.
But at that point,
Evaporation would
a
take it
drop
through that.
wouldn't even be able to.
Well, that's why he just poured up 2 pints and said, "Here you go. You
Yeah.
figure it out. Know your limits." Limits.
Alright. So,
That's why there was prohibition to record.